So welcome everyone to a new seminar of the GloBIAS series. We have the pleasure to have with us today Curtis Rueden, who will talk about Fiji with Python power, the best of both worlds. Curtis is a research software engineer in the Laboratory for Optical and Computational Instrumentation at the University of Wisconsin-Madison. Before we start, we want to remember what GloBIAS is. We are the Global Bioimage Analyst Society. We have more than 50 volunteers, 12 members of the steering committee, coordinated by one community manager. We aim to create a sustainable base and legal entity to promote knowledge exchange, foster networking, and professional development. We want to support the advancement of tools and best practices in bioimage analysis. We want to develop and share high-quality educational resources for different levels of knowledge. We aim to tackle challenges and seize opportunities in bioimage analysis. Our main goal is regularly organize in-person and online events. We thank the Chan Zuckerberg Initiative, which support us, and we are hosted by the German Bioimaging. We are a registered no-profit association for bioimage analysts, and you can become a member. So just visit the website www.globias.org in order to know how to become a member of GloBIAS. With this seminar series, we want to provide a dynamic platform for bioimage analysts, enabling the community to stay up to date with the latest development in the field. We have an audience that is more intermediate and advanced analysts, and we will focus on practical, high-level content that extends beyond the basic level. We thank the Broad Institute for providing the infrastructure for this seminar series. The seminar will be recorded, and questions will be later transferred to the forum image.se. So now I leave the stage to Curtis, which will present Fiji with Python power, the best of both worlds. Thank you, Curtis.
Thanks, Rocco. Gonna get my screen sharing started here. All right, you seeing a title slide?
Yes.
So I'm going to talk about the latest features of Fiji. I want to stress that many of the things that I will be talking about today are very new. They are the culmination of many years of work, and this work is still ongoing and continuing to polish things and fix the many bugs. The reason that it says the worst of both worlds is, as you might imagine, when you're trying to combine technologies together, which Fiji strives to do often, you can end up inheriting the problems of everything that you're combining. So we will run into a lot of rough edges today. I will tell you that right up front. And I'm also going to tell you that this is a technology demo, a technology preview, maybe is a way to think of it. What I'm not going to do, and for those of you who are maybe here for this and it may disappoint you, I'm not going to do a deep dive into a deep learning image analysis workflow in Fiji via Python. What I'm going to do is show you how these technologies work. I'm hoping that everyone here is either familiar with Fiji scripting, or at least with using Fiji a bit, or, and ideally but at least or, familiar with using Python scripting and using the powerful Python image processing ecosystem, tools like NumPy and so forth, or deep learning or both. So if you know any of those things, there'll be probably something for you to take out of this, but most of this is of interest to people who care about Fiji in some way. If you're happy already using Python to do your image processing and image analysis workflows, then I would urge you to keep doing that. And then if you're interested in bringing the power of that to non-technical users, I would then encourage you to consider learning more about Fiji so that you can target users using Fiji. because what you'll see today is that this platform is very promising for being able to deploy Python-based workflows to non-technical users. So as you may know, one of the major goals of Fiji is accessibility, maybe the main goal, accessibility, so that non-technical folks have access to these powerful routines, and then technical folks or anyone on the spectrum between, hardcore programmer all the way to non-technical scientist who just wants to click things. And everywhere in between, Fiji has a place for you, and there are good tools for you. So I do think it's the best of both worlds, but I just want to make sure that you're aware that yes, you will be inheriting some of the warts of Python and some of the warts of Java when you combine these things. So like I said, this should be considered a technology preview. My purpose for doing this workshop is to educate you on the tools, but also to get feedback on priorities. So like I said, many of these things are very new. There are bugs, there are missing features, there are things that it doesn't do yet that it's very close to being able to do. And there's only so many hours in the day and so much energy that I have. And so I would really love to hear from you after the workshop and on the image.se follow-up thread. We will discuss which of the things that I'm showing today are most exciting for you or most useful for you for your daily work. And then we can make a poll and we can vote and it'll be brilliant, and I will have some guidance on which directions to pursue first. Another goal that I have is to recruit help, because honestly, people who can program in Python are already most of the way there to being able to contribute back upstream to open source tools like this. And I'm just one guy. And even though I'm funded by CZI as an imaging software fellow, which I am deeply grateful for, again, I only have so much time. And there are many things that I have to do with Fiji beyond just these latest tools and the Python tools. So I need other people's enthusiasm and energy and contributions. This is something I stress in all my talks, but just I always need to mention this, that if you just wait for things to be done, it will take a very long time because there are so many things that need to be done. And like I said before, I will not be showcasing a deep dive into any workflows, but what I hope this lets you do after you see the technology today is that you could explore doing that yourself. You could pick your favorite Jupyter notebook. You could pick your favorite Python-based tool, like say Appose, for example, and you could start integrating it into a Fiji script or something like that, or combining it with Fiji plugins. Those kinds of things can be done now. And so this workshop will give you some guidance on how to start doing that. And then from there, it can be developed and eventually shipped to users via Fiji update sites and made much easier to use. So let's see here. You're probably seeing my Zoom crap. This out of here. I know there's this menu setting for it.
Actually, we just see the slide, so it's good.
So you're muted, Curtis.
I understand, because when I drag the thing, it clicks the mute button. There we go. Right. So there's 5 things that I'm going to be talking about today and showing you and going through with you together. So those of you who have Fiji installed, especially if you have this Fiji latest distribution installed, which I'll be talking about in a moment, will be able to follow along with the workshop portion later, especially people on Linux and Mac. I think Windows should be okay, but again, I'm guessing that what will happen is that the moderators are going to see a number of questions in the chat about my computer gives some error when I try to do this or that. That's fairly typical, but in this case, I think it will be more prevalent than usual because again, this is a complicated connective tissue of multiple technologies. So it is what it is. If you're able to follow along, that's awesome. If you're not, hopefully this is being recorded and you can still see things and it will point you to documentation and so on, and we will make it work. We have the forum for this. Just have to persevere. So the first thing I want to talk about is Fiji latest. This is not a Python specific thing, but it was critical for enabling a better Python integration and technologies within Fiji. So a huge part of this effort to update Fiji was to update to the new version of Java, which is Java 21. So for many years now, since at least 2015, Fiji has been based on Java 8, which is a great platform, but as many of you know, it's extremely old now, and it's missing many great new features that a lot of the Java developers wanted to use. So I worked very hard for the last couple of years on this tool called Jaunch, which is a new launcher. It's a native program that runs it runs Mac, Linux, Windows, x64 and ARM64, and it lets you launch programs in what I call non-native runtimes, in particular in Java and in Python. So it knows how to figure out which Java to use or which Python to use. It knows how to run the programs, and it knows which flags to use based on a lot of different configurations. So we will dive into that first, but I want to go through the different features I'll be talking about today as an overview first. So the second thing that I will be talking about that's enabled by the Fiji latest distribution now, well, PyImageJ is actually not necessarily requiring Fiji latest. It actually works with Fiji latest and the Fiji stable, which is still built on Java 8. But it is the second critical piece of getting Python working in Fiji proper. So if you have used PyImageJ, then I think that some of this will be familiar to you. It's just a slightly different context in how you can apply PyImageJ. But this is a tool for invoking Fiji from a Python. So imagine you're a Python programmer, you have a Python script, you can import ImageJ, initialize it, and then call Fiji functions and call ImageJ functions. That is, in a nutshell, that is what PyImageJ lets you do. And I will showcase some of that for those who haven't seen it. And for those who have seen it, it's a bit of review, but that's okay, I think. The third thing that I want to go through once I've shown the intro to PyImageJ is going to be using it in Fiji now, and how actually Fiji latest now enables access to PyImageJ directly in the script editor, which I think is quite neat. And for those who haven't seen Fiji script editor at all, I will very briefly explain what it is and show you how to learn about it. This is not a workshop on the script editor, but I can give a quick overview. The fourth thing that I want to talk about more briefly will be the napari-imagej project. So for those of you familiar with Napari, which is a Python-based image analysis tool, we have written a plugin for it that lets you essentially run Fiji from inside Napari. You can pop up Fiji's GUI. You can run Fiji plugins directly from a search bar on the sidebar. And so I will briefly show that. I probably will spend less time on it because I want to talk about so much other stuff. I want more time for that. And then number 5 is Appose. So this is a tool that I wish I could be working on more. It's a tool that started in 2023, February, at a hackathon hosted by Florian Hug at the Human Technopole in Milan. So that was a hackathon that was focused on how to make deep learning more accessible from Java. And all of these pieces, numbers 1 through 3, are a good start on doing that, but they don't solve a fundamental problem, which is that many of these deep learning frameworks are fairly heavy and require fairly opinionated dependencies. So you might need a certain version of CUDA, for example, to run TensorFlow version 1, but you might need a different version of CUDA to run TensorFlow version 2. You might then want to use a TensorFlow 1 model and a TensorFlow 2 model in the same image analysis workflow. And doing this right now is rather burdensome. You can use a kind of higher level workflow tool, like something built around Docker, for example. There's a number of these cloud-based tools that people are developing now, but they all impose some more learning curve, and they all impose some more performance penalties with all the encapsulation around these containers, So Appose is a slightly different approach. What it lets you do is build a Conda environment of your choice and then start another process, like a separate process, and then feed tasks to that process so that you can run things between multiple communicating processes. And then it has a mechanism for sharing memory, which is basically built on Python's shared memory module and an analogous thing that we wrote in Java, so that you can have your same image. You can read it into a named shared memory buffer, and then you can share pointers to that image across these different processes so that you don't have to copy your data. So the goal is performance while still giving you this flexibility of you could have a single Fiji script that starts a Python process with one set of dependencies to do part one of your deep learning workflow, and then starts a second Python process with different dependencies to do part two, and then finally aggregates all the results. So it gives you a little bit more power in how you structure your workflows as Fiji scripts. So I'm going to talk through how the API of that looks and how you might go about using it. And I'm going to briefly show a couple of examples of it being used in practice right now. But I will say right now that Appose is the least well documented of everything, by which I mean documentation is horrible. But the documentation for the other four things is pretty good now, or at least approachable, I think. So this is why I say I wish I had more time to work on Appose. But I do want to show you the current status of it in this workshop, and we won't play too much in a script with it because it needs some polish right now. But you will see how it works. So those are the 5 things. And from there, now I'm just going to start diving into each of these things, and you can follow along with your own installation of Fiji if you like. And if you don't feel like it, or if you get errors that make you stuck, that's okay. I will try to go slow enough so that people have a little bit of time to play, but fast enough so that people who aren't playing along don't get mind-numbingly bored. Okay, so the first thing I want to talk about is Fiji latest. For those of you familiar with Fiji who have downloaded it in the past, you may notice that now this download page has changed. You can now choose which distribution you want between latest and stable. The difference is that stable comes with Java 8, latest comes with Java 21, and they have different base update sites. So there's a new base update site called Fiji Latest that drives the Fiji Latest distribution. We are super close to deploying a migration tool that will take existing older Fiji installations and offer to migrate you to latest. This prototype is in beta right now, essentially, where it's functional, but we're testing on every platform. With this kind of stuff, the support on multiple platforms has been getting more and more difficult in recent years, with Windows and Mac OS requiring code-signed applications, for example. So this has made Jaunch more of a challenge to get really working properly on every system and to get this migrator working on all these different platform configurations. But my colleague Mark Heiner is the main person driving this work right now, and I do feel like we're extremely close, and within a matter of weeks, you will see legacy Fiji installations popping a prompt when you say help update to switch to latest. For today, I'm going to be working from a fresh Fiji latest. If you don't have Fiji latest already, you can download it by clicking this big download button. And what you will get is a zip file that when you unzip it has a folder called Fiji. So I'll just show what that looks like. On Linux here, I have unpacked it I made a folder in my home directory called apps. I unpacked Fiji latest in there, just a folder called Fiji. And you'll have various things. And the program that starts it is Fiji Linux x64. On Mac OS, you should have a Fiji.app launcher. So I have unpacked, I gotta quickly do this. My Mac Fiji, I've unpacked into, I've unpacked it and dragged the Fiji folder into my applications. That's what I have done. So now in applications, this is a change from how Fiji used to be. It used to be that you'd just have Fiji and it would have the Fiji icon and you double click it and it was all very nice and very Macy. And the only problem was Apple code signing has made this essentially impossible to keep working with Fiji's extensibility. Fiji likes to update itself. Once you update yourself, your code signing is invalidated and you have to re-sign. And rather than re-sign hundreds of megabytes of stuff, what we have now is a lightweight launcher. This Fiji here is 6 megs. So that's great. I'm going to make I don't know if everyone can see, so I'm going to make this slightly bit bigger. Or I would if there's a way to do it bigger. I cannot hit the command key, unfortunately, because I'm using VNC. Blah. In any case, you'll get this launcher. This launcher is code signed by me, and so that should launch Fiji latest no problem on a fresh Mac, including an ARM64 Mac, which this one is. I will tell you there are some limitations to Fiji on ARM64 Macs. In particular, native libraries all need to be signed also when you run in the hardened runtime, which means that if you run the 3D viewer, for example, it will crash. Let's try, just in case. We have our Fiji. Open samples. I'm just going to open up the T1 head, which is a nice example for trying the 3D viewer. And I think what we'll see is that this thing just crashes right out. Yep. So if that happens to you on a Mac, I would say I'm sorry, but really it's Apple who should be apologizing. They made this extremely difficult. But I will do my best to make it work. It's one of the things you'll be able to vote on in the thread afterwards. But a lot of the things in Fiji do work. Anything in pure Java works. And notably, the Python support will work, which is pretty great. All right, so back to Linux. Let's see here. There is a helper script to launch Fiji more easily, regardless of your platform. You can just type /Fiji from the command line if you want to do it that way. I will do it that way. You don't have to. You can also just make you can make a desktop file. I think Fiji already tries to do this for you, but we need to update this logic. So for now, if you don't have a convenient desktop-based launcher, you can launch it from the command line. If you don't like the command line, then I'm sorry. We're going to be using it a lot. At least I will, but hopefully you can do a lot of things in the GUI. All right. Ooh, you can see I'm actually running in Python mode here. I'm going to stop running in Python mode. And the reason that I'm going to stop running in Python mode is so that I can show you how to enable Python mode. Okay. Run Fiji in normal Java mode. So the way that this works now with Jaunch is quite different than with the old ImageJ launcher in some ways, but fundamentally it's the same. It's a native program that tries to discover Java and launch it with the right flags. A lot of the features you might be familiar with the ImageJ launcher still work. If you aren't familiar with the ImageJ launcher, then you can read about it, j.net, at /learn/launcher. And then there's a command line. Let's see here. There are command line options that are documented in here. Actually, I guess most of it. I guess this is how to use the updater. Okay. Good. So there are some features that are documented here. I'm actually just going to show you on the command line. If you type --help, this is using the new Jaunch launcher, but it will still give you a list of things you can do. Most of these things were preserved from the ImageJ launcher. When I created Jaunch, I tried to make the command line arguments inspired by or identical to the ImageJ launcher. So a lot of these things will be familiar, but not everything. If you run into problems that you were doing command line Fiji stuff before and Jaunch doesn't work for you, then please report this as a bug. For example, there's this function to run plugins. You can run side JavaScripts with arguments. This, I believe, is broken with Jaunch, or at least some people are having problems with it. And there's an active thread right now, so I'm going to help solve that. But we won't need to do that for today's workshop. I want to show you how Jaunch works a bit, and you can play if you wish. So let's see here. Give myself a 5-minute time box because I don't want to dwell on this for too long, but I want you to understand how it works. So there's a folder called config/Jaunch on every platform in your Fiji installation. And if you look in here, you'll see some files. The main configuration files are these TOML files. They control how Fiji launches. So when you launch Jaunch, Jaunch doesn't know anything about Fiji. It's a native launcher that can be used out of the box pretty much to launch whatever. But to figure out whatever, it looks in this Fiji.toml. So let's look in there. It's fairly like you can try to intuit things just by reading it, but if you want to learn about Jaunch, what you should do is you should open the common.toml. Actually, let's start there. I have written Jaunch's documentation into this file, and I have been fairly exhaustive, I think. If you find things that are missing or that you don't understand, again, write on the forum or you can ask in the chat if you want a verbal answer from me during the Q&A. But this is how you would go learning about how to use Jaunch and configure Jaunch. So it lets you do so many things that I can't showcase everything, but I'll try to give an example. You can see what would happen with the dry run flag to the launcher. Oh my gosh. Unfortunately, it puts many things on the class path, which makes it kind of hard to use. So I'm just going to put new lines with like an arrow for each. Oh, TR doesn't let me do that. Okay. Good. All right, so when you do a dry run, it tells you which Java is going to be used, and it shows you all the flags that are going to be used. There's a lot of things that need to get past to Fiji to make it work well with Java 17 and later, unfortunately, because Java 17 has become very strict about how Java reflection and the modularized core of Java work. So it's unfortunate, but the good news is Jaunch takes care of all of it for you. And I've also found a way to take care of some of it at runtime in Java itself too, which I'm excited about. And that means PyImageJ works better with Java 17 and 21 as well. All right, so let me give an example of some cool thing that you can do with Fiji. You can start, let's say one of the things developers like to do is run in an interactive debugger, which lets you sort of step through your programs. I won't be showcasing that today because I feel like it's too technical for a mixed audience. But you might be familiar with the ImageJ launcher's flag that does this if you have ever used or seen this feature. Let's see here. It's this JNLP thing. Where is it? Oh, maybe it doesn't work right now. Unfortunate. Okay, I'll give a simpler example. A very simple example would be to say -- Java home and give a different Java that I want to use. So this can be helpful for testing. Say I want to use this Java for some reason. Now you can see that it chose that Java, and that's nice and all, but if you want to understand why, then a very nice flag on Jaunch is the -- debug, which will tell you exactly every step of the way what Jaunch is doing and how it's interpreting these TOML files and so forth. So again, this is pretty technical, and you probably won't need to do it unless you're trying to add a feature to Fiji's command line support. But Jaunch now makes it possible for you to do that. So the takeaway here is that previously the ImageJ launcher had a set of options it supported, and that's it. That has now become extensible. So you can ship your own TOML files on your own Fiji update site, which add new command line flags that do whatever you want and can be configured to be transformed into arguments passed to Java or arguments passed to the JVM itself. And we can see where Java got discovered somewhere. Proceeding with Jaunch configuration. Configuring runtime. This is how you can see where it's searching for Java, and it tries very hard to find a Java in many, many places. But ultimately, it analyzed this one first, and I just want to quickly, momentarily show you why that was. In the JVM configuration, you can see this, it adds the --Java home option. This is not even a Fiji specific thing. It's added to any Jaunch program that uses this JVM toml configuration. And the reason that it chose that first is because in the list of root paths, it says if the Java home flag was given, then look in whatever value they specified for that thing. This is just the tip of the iceberg for Jaunch. I could do a whole 75 minutes boring you about it, but I just want you to know about it because it is a way to have more control, fine-grained control over how Fiji launches. And in particular, it makes possible launching Fiji from inside Python. So it discovers Python, it launches Python, and then it runs a very specific Python script, which for the Python programmers in the room, you may be interested in looking at, which is fiji.py, which is also in the config/Jaunch folder. This is exactly what happens when Fiji launches in Python mode. And it's overall not so complicated. It looks complicated because a bunch of boilerplate setup and so forth. But really what happens is PyImageJ is used. So if you've used PyImageJ, this should look familiar. Just initializes it, shows the user interface. That's pretty much it. Just takes care to set things up properly. All right, so that's Jaunch. And that also makes usage with Java 21 and 17 easier, not only because those flags get passed, but because the old ImageJ launcher was too stupid to understand the new layout of Java 9 and later. Java 9 revamped how Java is kind of structured under the hood. Even the directory structure changed. And so that broke the ImageJ launcher. And it was difficult to keep that tool working because it was like 5,000 lines of C. So Jaunch is written in Kotlin, multi-platform, it's easier to maintain. All right, so enough of that. Let's get into fun Python things. PyImageJ. If you've used it, hopefully some of this will be review. If you haven't used it, then this will just be a quick overview. The documentation for this I feel is fairly good, but if you disagree, please complain. This Fiji, as we are fond of saying, is a complaint-driven project. Py.imagej.net is where we have the read the docs for PyImageJ, and it talks about how to get started with it. One very recent advancement, we used to recommend always using Mamba Conda, but now you can install PyImageJ with pure pip, and it will bootstrap your Java installation for you thanks to Tally Lambert integrating Mark Suchida's CJDK tool into it. So these documentation, I think, currently strongly recommend Mamba, but the latest version of PyImageJ released a few days ago, 1.7, no longer really, I would say, needs this as strongly because it will bootstrap Java and Maven for you, which is quite nice. So if you want to learn PyImageJ, the best place to start is probably to get into these how-to guides. I'm going to jump down. Well, I guess I don't want to review the basics too much for the people who've seen this. A lot of you have probably seen this, and so this will just be tedious. But once you've initialized your ImageJ and you have this IJ, this is called the gateway, and you basically can do all the Java-centric stuff through this IJ object. So the main thing that you probably want to do is convert data between NumPy and Java data structures like the ImageLib library or ImageJ's image plus objects. And so this step 3 kind of talks about how you would do that, but the main way is to use the function ij.py.toJava, ij.py.from Java. And then you probably want to know how to run macros and scripts and plugins from PyImageJ. The section 7 talks about that. The main entry points here are ij.py.run macro, run script, run plugin. We will play with these, well, maybe not these specifically, but we'll definitely play with PyImageJ in a little while once we get to part 3. But I just want to showcase quickly one in-depth kind of workflow that you can do with PyImageJ. Let's just look at it. ImageJ Ops has been around since 2014. It is the ImageJ2 project's major way of invoking classical image processing routines like doing filtering, convolution, deconvolution, many other types of image analysis, component connected analysis, and morphological operations and so forth. This one showcases kind of how to get into that. I will put one caveat here, which is that we have now released the successor to ImageJ Ops, which is called SciJava Ops. That I won't talk about today, except to tell you that you can read about it at ops.scijava.org. It works very similarly. All the routines from ImageJ Ops have been migrated over, and it can be used from Fiji latest right now if you turn on the SciJava Ops update site. Again, we won't be doing that today, but I will say that SciJava Ops is going to move into the Fiji core very soon. The main obstacle to doing that before was that it requires Java 11 later. And we were stuck on Java 8. But now that Fiji latest is on 21, I'll be able to shift SciJava Ops bundle it as a part of Fiji. But this is the page the site that documents how to use SciJava Ops. And hopefully this documentation will get better, and we'll also have a nice Pythonic wrapper around it in the future. So right now, I think this script here just uses SwiJava directly and probably converts stuff, but we'll have a better approach that's more Pythonic. That's our next step for SciJava Ops. Anyway, if you read this ImageJ Ops tutorial, it's not completely obsolete. It still talks about how to use these things from PyImageJ, and a lot of the things in here would apply for both ImageJ Ops and SciJava Ops. Sorry, there are so many layers to things, but this is how development goes as you keep improving on the status quo. Okay, so you can try these notebooks anytime, but I'm just gonna jump to part 3, I think, because that's where we can actually start invoking PyImageJ stuff. Okay, part 2.5. So I want to just show you that Jaunch lets you launch in Python mode, and you can use the REPL. For that to work, initially what you can do is pass the ---- Python flag, and then it will use Python and run this Python script with all the same arguments afterwards, instead of launching the JVM, and it'll run that Fiji.py that I showed you. So, okay. You don't have to don't follow along with this part or any of the parts so far. I'm sure it's not really been coherent. We'll get, again, part 3. There will be hopefully the ability to do things. But just to showcase really quickly, if I have, oops, that's conda deactivate. All right, if I say Mamba activate PyImageJ, let's do Mamba and list first. The goal is for non-technical users to never have to use the command line, never have to jump here and type Mamba anything. You'll see it momentarily, but I want to showcase that even now, if you do like using Mamba, and you do have an environment that has packages in it, so this particular activated environment, as you can see, has a lot of packages, including PyImageJ. So now if I type Python and I type import ImageJ, I type ij equals imagej.init, then it will bootstrap and initialize an ImageJ instance. And you can see that it's version 2.15 of ImageJ 2 with support for the original ImageJ at 154F. Unfortunately, on Mac, there are issues with showing the GUI. Okay, so let me do it one more time. Import ImageJ, ImageJ equals imagej.net. By default, it initializes in headless mode. But if I say mode equals interactive, that will allow Java's GUI to be active. And I can show the GUI. On Linux, this is great. Now I have an ImageJ, and I also have a Python REPL. So let's see what I got in my data folder. I've got an OME TIFF file, cfo/sw.ome.tiff. Data.ij.ui.show data. There it is. So this is very powerful. This is a powerful way that you can combine PyImageJ with Fiji GUI, and you can do things in the GUI, and you can then do Python operations. So even without having support for PyImageJ in the script editor per se, this is a way I very much like developing because you get the power of Python's REPL. You could also use IPython or Jupyter Notebook in a similar way, except on Mac, which we'll get to in a moment. Okay, I'm going to now quit Fiji. I could quit Fiji graphically, but I can also just quit Python and it'll close it down too. All right, so now if I run Fiji in Python mode and pass the -i flag, that will feed the -i flag to the Python launch, and I should still get the REPL. There is one important difference. For Mac people, this does pop a GUI, does give you a REPL, and does let you do things interactively. And I should probably actually showcase this on the Mac so that you can see that it actually works. I'm going to prove it to myself that this actually works. /Fiji Python -i. Ooh, I don't have an environment. That's just my shortcut for Mamba activate. So now, Fiji in Python mode. Apple has what's called the core foundation or app-kit event loop that must run on the process's main thread. And Java has its AWT event loop that has to run as well. And if you're using Napari or NDV or tools like that, then it has the Qt event loop, which has to run on a dedicated thread as well. So it can get quite tricky on Mac to make sure all these different event loops are running properly. At least for Java and Mac, if you use the Fiji with --python -i, it will take care of this for you. And the way that it takes care of it for you is that Jaunch, the Jaunch launcher, starts the core foundation app kit Mac event loop. And then it launches Fiji on a separate thread. This is exactly how the ImageJ launcher has worked for many years on Mac. So even without Python, forget Python, just Fiji on Mac. The ImageJ launcher classically worked this way, where it would start that Mac event loop, and then it would launch Java on its own thread, and it works. And so Jaunch has maintained that behavior, and as a bonus, what you get is a Python REPL that you can then start using. I don't even have to initialize my ImageJ, it's already there. And it will be a PyImageJ that has wrapped this local installation of Fiji, as opposed to bootstrapping one from the internet, which is what happens if you just say init. Whereas, let's see now, if I say Python import ImageJ, ij equals imagej.init, mode equals interactive, you will get this annoying error about limitations on macOS. So I'm doing what I can to try to help overcome or sidestep all of these limitations on macOS. It's just very tricky. So for now, this Fiji -- Python -I is a nice way to go. All right, finally then, let's get started with Fiji as a GUI. If you have Fiji latest installed, you can launch it. And I want to show you something that is brand new. In your edit menu, in the options, there's a new thing, Python. If you don't see it, then you might not be running Fiji latest, so download a fresh Fiji. But also, you might not be fully updated. So you can run help update. See if I can even click it. There we go. Help update. This runs the ImageJ updater, J2 updater, I should say. And then if you see any updates, you would want to apply those and then close. My Fiji has all the latest stuff, so no updates for me. However, that means that, yes, fortunately, that means that I now have this edit options Python. So hopefully you've tried it. And what you'll see is that it defaults to a Python environment directory that's in your Fiji folder it's analogous to where the Java is kept. So for those of you familiar with how kind of Fiji bundles its Java, it puts it in this folder Java, and it puts it in a platform name. So that way, if you want to have a Fiji that you can put on a USB stick, this is a so-called portable application, you can have a copy of Java for every platform that you want on your USB stick with the same Fiji, plug it into whatever computer and launch it, and Jaunch is smart enough to find and use the correct Java. That is why we keep the Java not just bare in a folder called Java, but we keep it underneath. And so what I opted to do for Python is something similar, but you can see that I don't have a Python folder here. So this folder does not exist. Now, if you love Python environment management, which I'm sure you all do, you can of course go here and type conda create blah, 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 and make your environment. And you can make it in a particular folder. It'll be in probably, I guess it'll be, let's see here, somewhere in your MiniForge installation or wherever, whichever flavor of conda or anaconda or mini conda you're using. You can take that environment, you can copy that, and you can make that be your Python environment directory. That is okay. The only rule is you got to have PyImageJ installed in it. If you do not install PyImageJ into your environment in question, then the Fiji Python mode will not launch. However, I'm guessing that a lot of people probably don't particularly care to manage environments manually. And so therefore, there's this button, Rebuild Python Environment, which will do it for you. This is the beginnings of non-programmers being able to start really harnessing the power of Python from Fiji proper. So what this is now doing is it downloads Micro Mamba, which is a single executable standalone installation of Mamba Conda, basically. And it is utilizing that to build an environment. What environment, you might ask? So that is this one. In the config folder of your Fiji installation, you should have an environment.yaml. For those of you who care about such things, you can look at it and see what it's doing. You can see what I've opted to do here. If you are familiar with Conda, what I've opted to do is that I've set Python to 3.12 because I know that one works well. There are a few rough edges with 3.13 and napari-imagej right now, so I've opted to stick with 3.12 for the moment. And I've installed pip, of course, because I want to install all these other things. Yes, a lot of these things are on CondaForge. Yes, you could put them as regular dependencies. For Fiji right now, I've opted to ship them as pip dependencies because it installs faster. Or at least, because Mamba's has what's called the resolver, the dependency resolver. It's so slow, unfortunately. And so This is much faster because it just says, oh, I can resolve an environment with Python and pip, no problem. So then it initializes that, and then it installs everything else with pip. I'm not using UV yet. For those of you who are on the cutting edge of Python, I will say UV is awesome, and I will be investigating ways to utilize UV more with the tools that I'm showing in the workshop today. But for now, it's still built on MicroMamba. Oh, I'm not using Pixie either. And that was, I guess the next step is to kind of convert this environment builder thingy from MicroMamba to Pixie, because Pixie is about twice as fast. But it's still ultimately driven on ContiForge, which means that its solver can be kind of slow still. Anyway, I've rebuilt my Python environment. Hooray. Hopefully you managed to build one on either Linux, Mac, or Windows. Feel free to complain if not on the thread, and we will make it better. But at least for me, it worked, and I now have this folder, Python macOS ARM 64, Mamba and list, and it's even listed in my Mamba environment, Conda environments. I don't really love that it's listed, but that's what MicroMamba does, so whatever. It's there as a nameless. So you can even activate it. Mamba, let's see. Activate. I guess I should just do it that way. So now this fresh environment that I just built, I've activated on the command line. Do you need to do this? Not unless you want to start up a Python REPL or something and start doing stuff. But you can. It's an option. Activate. Fortunately, non-command line jockeys don't have to do that. All you have to do is check launch in Python mode and hit OK and restart Fiji. So I will show you what that did. That has created a config file called fiji.cfg, created or edited. And in this file, you'll now see two lines. One says where Python lives, and the other says what mode we should be launching in. By default, Fiji launches in this so-called JVM mode, but that edit options Python dialog tells it, if you check that box to launch in Python mode, tells it to launch mode equals Python. So now when I restart this, it will probably not work due to a bug that I will. Oh, it works from the command line actually, I believe. Let's see. Hooray. You will know that it worked because it will say Fiji is just PyImageJ. That is a tweak that we make to the title bar in the Fiji.py script, specifically to make it a little easier to tell that you're running in Python mode, because right now everything else is exactly the same. It doesn't really, Fiji on the Java side doesn't really have any way of knowing. There's only a couple little telltales, and the GUI itself isn't hooked into them yet. So I just changed the title bar to say this. You can see that I now was able to pass the -i flag without --Python because we were in Python mode. If you get an error, something like no Python installation can be found, this happened to me earlier today when I was testing this on Mac, then I was able to fix that by editing this config file, this fiji.cfg, to use an absolute path. So here I happen to know that my Fiji is in /applications/Fiji/. So you can certainly do that to fix the no Python installations found problem if it happens to you. The reason that I tried to not put an absolute path is so that you could, again, make Fiji portable, put it on a USB stick and take it around different computers. And then, of course, it still has the platform here. So that's not completely platform agnostic, but it would at least allow the Fiji to be copied around without breaking Python mode on your Mac, for example. Okay, either way, it will work, whether or not the path is, for me, it's working relative as well. So hopefully you're able to get Fiji is just PyImageJ. The next thing we're going to do is start the script editor. So you can say File, New Script. There is a shortcut for this that unfortunately doesn't show in the menu, which is the left bracket, square bracket symbol. So all you have to do is push the square bracket or maybe Control square bracket or Command square bracket. That's this symbol here. I'm going to switch away from Mac now, just because I can't hit the command key because of VNC, which makes it more obnoxious to use Fiji shortcuts on the Mac in this particular view. But I just wanted to show some of those specific Mac concerns. So let's switch back quick to Linux and launch Fiji that way. And I already have initialized my Linux Python here using that rebuild environment. Let's just launch it and see what happens. It looks like I'm not running in Python mode, so let's fix that. Edit options, Python. I have high DPI woes. Launch in Python mode. If you click this button, it will always tear down the environment and rebuild it. But it will, right now at least, what I opted to have it do is back up your installation, your old environment to a .old. So essentially what that button does is deletes any .old that's already there, renames your thingy to .old, and then makes a new one. I have found personally with Conda that Conda update does not work as well for me as just rebuilding the environment from scratch. I have had numerous problems doing Mamba update, Conda update, various flags, update all packages, whatever. I have not gotten anything to work well. If you have, please feel free to share that in our thread later. But for now, the way that this builder works is that it always just rebuilds it from scratch. And that way it's guaranteed to kind of simulate a fresh experience of everyone else. And if it stops working, it means it's not working for everyone. So I kind of like that actually. All right, let's restart in Python mode, shall we? So I think that I've taken quite some time to explain all these things, which means we have, what, about 15 minutes left, I guess. So I will try to speed up a little bit. File, new script. Now that I'm in PyImageJ mode, you will notice that when I switch to this, there's a language here called Python SWI-Java. And I don't love this name. We might change this name. It's confusing, but it's because it's backed by a library it's backed by this library called SWI-Java, which is what drives PyImageJ as well. PyImageJ, not PyImageJ, is backed by SWI-Java, which is backed by JGo and JPipe, which is backed by Maven and OpenJDK. That's kind of the stack there. Oh, and I forgot a package actually. There's another package called imglib, which is the image data structure version. And this font is tiny, so let's make it bigger. All right, finally now, I hope that at least some fraction of you have been able to achieve Fiji is just PyImageJ, been able to achieve now a language Python SWI-Java, and we can test it. So we're going to put a parameter for the ij. Normally, when you do this in a Sci JavaScript, which I'll talk about what that is and I'll review momentarily, but normally when you do this, it's a Java thing. It's what we call the application gateway, and it'll have all the functions, ij.io, like I used earlier, .open data, .tiff, this kind of thing. However, when we're in PyImageJ mode, this thingy, it still acts as a gateway, but it has this new ij.py, which is part of PyImageJ, which if you read py.imagej.net, you can read about how that works, but it has the additional functions. Let's actually just try that, see what we get. Well, there's a lot of things. Fortunately, that's not very helpful. Maybe that'll be easier to read. For those of you who've never programmed Python, this part will probably be kind of mind-numbing because I'm not going to teach people how to program in Python, but I hope that for most of you, that's a good thing. So, unfortunately, very unfortunately, there's no tab completion yet, no auto completion for this script language. The script editor in Fiji does have autocompletion, courtesy of Robert Haase for some languages, notably the ImageJ macro language. There is nothing fundamentally stopping us from adding autocomplete support. It's just something somebody has to do. It's one of many things that I would like people to vote on stuff that they think they need sooner. The reason I personally haven't felt this itch, so to speak, is because of the REPL that I showed you a moment ago, that here you can do the tab completion down here. So this combo of Fiji minus I in Python mode, plus having actually the Fiji script editor open, is a very nice combo, because I can figure out what I want to do down here with the REPL, and then I can sort of bake it into my script as I go up here, and then click run to make sure that it works. So yeah, so I hit IJ tab and I can see all these different functions. IJ.io seems maybe like something I would want to do. Fortunately, you can't tab complete that, but you can do this. IO equals IJ.io, IO dot tab. Now I can see all those functions too. So this is kind of a decent way of exploring ImageJ2's API. I mentioned that I was going to give a quick overview of the script editor and a quick overview of ImageJ2. There is not time to properly do that. That would be its own workshop. However, I do want to point out that you can read about the script editor here, imagej.net/scripting. This talks about different languages in the script editor. If you click on this link here, script editor, you can actually see kind of an overview of how this works. So this is a nice tutorial into the script editor. What it does not teach you how to do is use the ImageJ2 API, this IJ gateway thing. So that you can learn as well. ImageJ basics. What does ImageJ provide? Scripting. That's this again. Oh, it says at the top, getting started, read the ImageJ2 tutorial notebooks. This is the main entry point right now into how to use ImageJ2. They're written in Jupyter in a dialect called Groovy, but Groovy looks very much like Python. So if you're familiar with Python, many of the things you will be able to copy and paste with no changes into a Python or PyImageJ script. Let's see. What I would recommend starting with is probably this first tutorials and demo, which showcases, you can ignore this. This is the Groovy centric way of initializing. What you're going to have already is an IJ. And so you can then start reading kind of how to do stuff. Computing histograms, opening images, converting between types. There's a number of things that are showcased in this introduction. This probably is not relevant to Python. One thing that's a wealth is the ImageJ ops tutorial, this one right here. ImageJ ops. This is a large notebook, and it showcases a lot of different things. If you set up the tutorials using the Conda environment that is in this repo, this tutorials repo, in ImageJ/tutorials on GitHub, then you will get not only Jupyter Notebook installed, but you'll get the nice table of contents support. So instead of having to like click through everything here, you'll be able to see a table of contents. On GitHub's browser, unfortunately, we don't get to see that, but you can also just Control F and search. So for example, here's some stuff about convolution. It shows you how you would go about using ImageJ ops, which is entry point ij.op. And soon to be SciJava ops accessible in this manner as well. Stay tuned for that. So I don't have more time to go into how to use ImageJ2, unfortunately. This is kind of what I meant when I said worst of both worlds. You have to learn Fiji, you have to learn Python, you have to learn NumPy, you have to learn scikit-image, you have to learn ImageJ ops, you have to learn ImageJ the original, you have to learn ImageJ2, you have to learn Fiji's extensions. It just goes on and on. But when I say you have to, you don't have to. You should learn the things that you need, ask about the things that you don't. And thankfully, in this world of LLMs, it's a lot easier to get bootstrapped in any individual subtopic here than it used to be, which is very nice. If you haven't already tried using things like ChatGPT or Claude, they are incredibly valuable tools. I know that LLMs are hyped a lot. A lot of people like to hate on them as well. I think they are a two-edged sword. But for example, I wanted to know how to escape Unicode just this morning. So all I had to do was type this, and it tells me how to do it. I tested it and it works. That's the main takeaway, though, is whatever it's code it spits out at you, just test to make sure it works. And most of the time it does, my experience. Okay, so let's see here. I'm not going to spend a lot more time playing. Hopefully you spent some time playing while you listened to me ramble on. But again, we can put some data this way. Let's let's see, what is this thing that we get? What do we actually end up with when I run this? It is a Java object. So this is JPipe, which under the hood will wrap every Java object into a Python object, which is very cool. But what this data thing notably is not, is it is not a NumPy array. It does pretend to be a NumPy array with duck typing in a number of ways. Oops, that I don't want the type of the shape. I just want the shape. So you can see it gave me a shape. What's actually neat, though, is that I can convert it from Java. I can make this thing, and then we can see what is that. You don't have to use, if you want this stub image, by the way, not that you need it, you can go to sif.io slash, all right, images, sorry, images. All the sample Sifio images are here. These are nice for testing. Dub is the full data set, and stub is a downsampled version. Is stub on here? Yeah, it is. Okay, good. So yeah, you could download it and unpack it. I've converted it to OME-TIFF, though, in this example. It comes as a .pic file, but you use bioformats. This will also use bioformats as needed under the hood. Okay, so now that I have this X array, then I can feed X arrays can function as NumPy arrays completely, but they have extra metadata. So you can feed that to whatever you want, like scikit image routines, for example. But it has additional metadata, like I said. So I print out the dims of it. You can see that it preserves the axes, which is quite nice. Sadly, Napari doesn't yet understand X-array, last I checked, as of a couple months ago. Someday it will, hopefully, and then you can feed this to Napari more easily, and it will do the right thing in more cases. A downside of Napari is this metadata issue, which is a strength of Fiji, I think. Although it's still complicated, and we're working on making it better in imglib 2 right now. It's a separate topic. All right. So hopefully this is just like the very basics of the technology and how you see that I can get these things working in the script editor, how you might be able to develop a script. We are running short on time, which isn't really shocking. So let's return to, I'm going to skip napari-imagej, unfortunately. What I will do is just showcase what it looks like. It is also driven by PyImageJ. It works pretty much the same way in that the plugin for Napari calls imagej.init on demand the first time you need the JVM for something. So Java is not started until you actually launch the plugin from the plugins menu. If you want to see a cool use case for napari-imagej, then I would recommend checking out some of these tracking use cases. I really think this is cool because you can combine the data structures of both Fiji and NumPy Napari. So this uses TrackMate to do the tracking, but then it visualizes the tracks using Napari's tracks layer. And it also, I think, does something with another Napari plugin for tracking. Let's see. I guess I don't really need to scroll down. But I would recommend looking through these use cases. If you're interested in using Fiji functions with Napari, this is kind of the best in class thing that we have so far. A downside is that I think that on Mac, you can't pop the Fiji GUI. But otherwise, on the other platforms, you can click the little Fiji icon and see, or ImageJ2 icon, and see a Fiji GUI next to the Napari GUI, and then there's buttons to send the data back and forth. So this is something I'm very keen to find out how many people care about this plugin, because we haven't gotten many bug reports or forum posts about it, and I'm wondering if anyone really cares, because it's pretty niche. I think it's nice for users, but a lot of users maybe just use Fiji or just use Napari, maybe in some cases. And combining them is a small Venn diagram. All right, so finally, Appose. I only have a couple minutes, but I want to just show what it is. The documentation, like I said, is not good, but what it lets you do is invoke Python from Java. It also lets you invoke Python from Python and Java from Java, but our main use case is this easy execution of Python-based deep learning from Java. So what you could do in Fiji, and this is even without running in Python mode, you could just be a plain Java mode, none of this bootstrapping anything. And you could write a script that calls the Appose API in order to build a Python environment, start it, feed scripts to it, and harvest the results. I am sorry that this workshop can't give you a really kick-ass, go-to example yet. I feel like this is very close, except that I have too many priorities. That's the main thing. If you vote on this, it'll get done faster. That's all I can pretty much say. Okay, let's look at a test here. This test showcases it. So this is Java code. What you do is you construct an environment, and then you start a Python service. I'll make this a little bigger. In this case, what I've done is started an environment around a particular Conda environment file. And this Conda environment file is super small. It just installs this package called cowse using pip. But it lets us use it, because then what we can do is once we start the Python service, we can make a task. We can import that library and we can call some function on it. We can assign that result to the task outputs. Once it's done, then we can grab the output on the Java side. In this case, this is a string. Strings get sent back and forth. They get marshaled or serialized, if you will. It uses JSON to do that under the hood. But for the shared memory pages support, you can construct if you allocate an array in shared memory, you can pass the name and the shape of it to your script. And then it will allow you to work with it as a NumPy array on Python side and as an ImageLib2 image on the Appose side. And that work is enabled by this other library that's built on top of Appose called imglib2 Appose. So this is where the logic for doing end-to-end arrays on top of Appose is coded on the Java side. On the Python side, it's a couple lines of code to go from a shared memory buffer to a NumPy array. So there's not really the need for a library, but we might make a convenience function or two eventually as needed. So because I'm so short on time, I just want to show quickly a couple things that are using Appose in the wild so that you know it's not vaporware. It is working. There's still a lot to be done. It does not work on every platform flawlessly. For example, probably it does not work on macOS in the hardened runtime, which is annoying. But that's because Appose needs to use a tiny little Mac shared library, and that shared library is not signed yet, so we have to sign it. But that will happen. So this is work by Stefan. I'm blanking on his Stefan Hamann. He has been helping to drive Appose forward. He has fixed a couple of Windows bugs, and he has integrated it into Mastodon, which is the next generation tracking plugin for Fiji. That's been in development for like 10 years by Jean-Yves Tinevez and Tobias Peach and others. It scales to very large numbers of tracks. And just like TrackMate, it has a number of these so-called detectors. What we really want is for these detectors to be able to be driven by deep learning. And so you can see here demonstrating some of the detectors that are driven by Appose. Under the hood, what happens is Appose builds the Python environment, like I said, using its builder, and then it feeds the scripts using tasks. As a quick aside, since I know I'm out of time, one of the last things I'll mention is that rebuild Python environment button that we clicked earlier to make our Python environment, that is also backed by Appose. So Fiji latest now ships with the Java side of Appose, and the environment that is built, let's see, installs the Python side of Appose. So in theory now, you can start writing scripts in Fiji that utilize the Appose API. Again, if you want to see how to get started with that, I would just go to the README, appose.org. If you scroll down to the README, it says examples. You can click Java, and you can see a couple of basic example, more complicated example, and then the example that builds an environment, unfortunately, isn't in the README yet, but again, it's in the source test, this folder, Appose test. You can see that being done here with the builder. So it's not super complicated code-wise to do it. It's just really brought under the hood to make sure everything works. Oh, the last thing I wanted to mention here with Appose being used in the wild is the SAMJ plugin. I don't know if any of you have tried this plugin. It is mostly by Carlos Garcia and a number of other contributors, Vladimir Ullman and Daniel Zaj and a few others. There'll be a paper very soon, but you can add the SAMJ update site to try it. I will show that this, sorry for the GIF quality here, just very downsampled, but you can see here the SAMJ has its own window. It builds the environment using Appose, and then it works using Appose. What you do is you can do a manual annotation where you click stuff. It's segment anything, so you click stuff and just selects it. This is the live mode. Or you can do preset prompts. This is my favorite feature. So here they're doing find maxima, which is just a age-old Fiji thing to get all the maxima dots. And then once the maxima have been found, then it can be segmented using Appose. I need to shut up now because I know that I'm short on time and I want to answer some questions. So with that, I will stop there. Thanks for your attention so far.
Thank you very much, Curtis. I will pass on to Esteban Milleta, who is helping, and he will just report the question we have got. Thank you very much.
For sure.
Thank you so much, Curtis. That was a lot of information, and it was so cool. I will quickly run through some questions. Omar asked, which JVM would you recommend to install first for those using the latest portable version of Fiji? He was thinking of using Corretto, but wanted to know if there's anyone that was preferred or widely supported.
Yeah, so we've seen an explosion of different flavors of OpenJDK lately. My favorite is Zulu, azul.com, Zulu. So here you can get pretty much builds for any platform all the way back to Java 8. You just scroll down a little. You can even get Java 8 builds for Mac OS, ARM64, and so on. The other thing you can get is you can get builds that include JavaFX, which is nice. So if you download Fiji Stable, the bundled Java will be this, Java version 8, JDK FX. This is important for the JavaFX-based plugins to work correctly. For the Fiji latest now, what we're shipping is JDK, just Java 21 without JavaFX because we ship the jars separately now. That has some advantages in other deployment scenarios. And whether you get the JDK or the JRE is really up to you. The JRE will be like 200 megs smaller. The problem is that if you like Fiji's like kind of dynamic Java features, then you want the JDK. So the main thing you can't do with the JRE is you can't use this Java language, although it's kind of broken in Fiji latest right now anyway. That's another thing we need to fix. But the JRE won't let you use that, and it also won't let you run .java files. So I don't know if you're a fan of old school ImageJ plugins from the original ImageJ website, which is at imagej.net/ij. Click in here, but if you go in here and look at plugins, a lot of them are made available as a single, like whatever .java file, and the instructions say drop it into plugins, it'll run. For that to work, you need a JDK. Otherwise, JRE is fine.
Another question is, can you say something about GPU support in Fiji? Is Fiji GPU accelerated when a GPU is found? How about multi-GPU? And can we have DOS switches in the Jaunch installer launcher?
That's a great question. So the short answer from the Java perspective is no. It's not GPU accelerated in the sense of Fiji doesn't really come with many things that work on the GPU. The exception to that is Klidge and Klidge 2 by Robert Haas. This is GPU acceleration in Java for Fiji and friends. And it works using OpenCL. So I think you might need to take care of making sure your system is sort of set up for that. I haven't used it extensively myself, so probably you'll have to ask on the forum. But I guess my real answer to that question is I feel like Conda gets us most of the way there now, by which I mean the problem with GPU acceleration is you have to install all these native libraries and you have to install specific versions of CUDA and specific driver versions and so forth for NVIDIA. All of that is very complicated. And with Conda, you can mostly create a Conda environment that has the stuff that you need for whatever your particular framework is. And so using Appose is the answer that I would give. I think as Appose becomes more polished and mature, what we'll see is Fiji scripts that are backed by Python environments that are GPU accelerated, if that makes sense. The other GPU acceleration stuff that's in Fiji right now is the SciView plugin, the 3D Viewer plugin. Those are using sort of traditional OpenGL or Vulkan technologies as opposed to like shaders. Well, SciView uses some shaders as well. But for GPU programming, the vast majority of Fiji's plugins are written in Java. They're not GPU accelerated. I hope that answers your question.
One very, I think, more general question is, can you say something about what is the strength of ImageJ compared to Napari, or why should we choose ImageJ? And can we integrate AI models as extensions to ImageJ?
Sure. Yeah, I think there's a lot that could be said in different elements of that answer. I guess what I'll say is Fiji's main goal is accessibility. I think one of Napari's main goals is also accessibility, but Juan Nuno Iglesias, the guy who is the main Nunez Iglesias, the main guy who is maintaining Napari and developing it along with the Napari core developers, he puts it this way. Do you like Python? Do you need a GUI for working with images? Then Napari is for you. So that's when you should use Napari. Or also NDV. I didn't have a chance to showcase that, but another really lightweight viewer by Tally Lambert more recently is NDV, if you haven't heard of it. It's more like the original ImageJ. So you could also choose that. And it's also built on Qt, and I think to a limited extent, I don't know how mixing and matching works yet, but as you can see from the GUI here of NDV, it looks very much like kind of an ImageJ image window. And that's intentional to make it a little bit, quick to use. It's not as high powered and extensible as Napari. But Fiji is much more mature. It's also full of many old legacy cropped things. And so I would say use Fiji if you're already familiar with it. Use Fiji if it has a plugin that you need. And if it has like one plugin that you need, but you really want to be in Python, then look at PyImageJ and see if you can call it from there until a Pythonic replacement is more accessible. I could go on and on about this topic. My goal is not to like evangelize Java over Python. Quite the contrary. I could imagine in the future, for example, a Fiji GUI that almost every item in the menu is just a Python script. But right now it's mostly Java. And there are advantages to that. Java is faster. The downside is it has to be compiled at least on the fly, if not in advance. And later versions of Java have become more burdensome to get around some of these security limitations with like the Java module system and stuff. So I think Python is the way our community is, obviously has gone, is going, will continue to go. But the Java stuff is very powerful too. So I'm going to keep maintaining Fiji. That's my job. I'm going to keep developing Fiji to make it more and more Python friendly until it becomes difficult to even tell the difference. I hope that answers the question. There's no one Swiss Army knife that solves all use cases. So use what works for you.
I think a quick one is the Docker hub for Fiji still maintained?
Great question. No. It should be. I think that, let's see. So one thing I can show you is there's this project board, github.com/Fiji, that we're maintaining to try to address a lot of the terrible like maintenance challenges and user burdens of Fiji, just to make it nicer, right? Bring Fiji into the 21st century. And I think Docker is in here. Oh, it's not even in here. But so things that are in here include things like make it work with Flatpak. Wonder if the search is just not working. Yeah, add Flatpak support, for example. Somebody even did a PR years ago, and I just have not had time to double check that it's all working. But yeah, so github.com, what is it? Fiji Docker, some Docker files or something. I think someone else did it originally, and then Mark Heiner updated it, and then Josh Moore updated it a bit, and now nobody's updating it. So if you want this, help wanted, I would love help. I love Docker, but I don't use it every day personally. And if you use it every day and this would help you, then getting Fiji latest on here would be awesome. So yeah, that's where we're at.
And I think we have still a few questions left. Most of them have to do with errors when running in Python mode. For example, someone says, looks like I can't start Fiji after Python environment was built, and I checked the Open Fiji in Python mode. I'm on a Windows 11 system and just downloaded both JDK or JRE zip files for the latest Fiji.
Perfect. So I didn't test on Windows, unfortunately. I have used this on Windows in months ago. Jaunch fundamentally works on Windows. The way that I would suggest trying to troubleshoot this in any scenario is to drop to a command prompt or PowerShell, whatever your preferred shell is. Git bash also works. I personally like git bash on Windows. And then what you want to do is launch like Fiji.bat with the -- debug flag, and then read the output. It's important to use the Fiji.bat wrapper script because Windows has an issue with consoles and GUI versus Win32 versus GUI applications and so forth. So if you launch from the command line, I recommend launching with Fiji.bat, but you should have this file in your Fiji latest. So the -- debug will at least tell you what's going wrong. It's verbose, but that helps if you want to post that on the forum. So yeah, sorry, without seeing the output, I don't know that I can necessarily give a better answer, except that it is a super high priority for me to make this work on all platforms. The Fiji Python mode, that's a higher priority to me than getting Appose working well, even though I think Appose is a very important project for the future of Fiji. The present of Fiji is this Python mode thing, and I really would like to have it work on Windows. So if you don't hear from me within the next day or two, I will test on Windows probably today or by the end of the week. If you don't hear from me that it's fixed and it's not working for you, then complain, please.
We still have more questions, but I think we are reaching the time, so we'll move those to the future thread in the ImageJ forum.
Sounds great. The good news is that I'm in the US, which means, I mean, this isn't actually good news these days necessarily, but for the purposes of this workshop, there are still like 5+ hours in my workday, which means I'll have plenty of time to respond to all your questions, hopefully.
Okay, thank you very much again, Curtis.